So now the workshop will continue with a further presentation from an operator. The title of the presentation is Exploring the Regulatory Implications of Software Networks, and the presentation will be held by Diego R. Lopez, Head of Technology Exploration, Global CTO Unit of Telefonica IND Spain. He's also actively participating in several standard development organizations activities. For example, he's chairing the technical steering committee of the SDN and NFV ISG, and also participating in the work of ONF and in working groups of the IETF, and also represents Telefonica at the European 5G PPP initiative. Welcome, Diego.
Thank you, Wilhelm. I'll try to be, since this is the worst time. It's much worse than Marcus was complaining about being between you and the lunch, because this is your siesta time. Even if you're not realizing, you're feeling a little bit drowsy and a little bit, whatever he says. So I'll try to be even a little bit, I'll try. Not that I will succeed, but I will try to be a little. Yes. No, it seems that. Thank you. So normally, when I used to work for the academic sector, something that was a joke about Microsoft not behaving good and why we should be using Linux and things like that. Anyway, I will spare you this. So to start with, as Stephen did before, is a disclaimer. I work for the research branch of Telefonica. I'm part of the innovation team, so this is a disclaimer. This is not the official position of Telefonica whatsoever. This is some reflections from the software networks team and what we are doing in the innovation branch. We have been discussing this internally and reflects reasonably what is an operator's view and how we intend to evolve our services and infrastructures based on SDN and NFV, but it's not necessarily, again. And I'll try to be a little bit provocative in some of the statements, because I think that is interesting in the fostering further discussion, because it's part of why we are here. So just to start with, these are the basic concepts we're talking about. On the one hand, we have NFV. On the other hand, we have SDN. That's very often they have been intentionally mixed in several directions. But just to make things clear, when we're talking about NFV, we're talking about precisely separating functionality that is implemented in general purpose in implementations that are running on software, and that part of the software, pure software implementation, running on top of a homogeneous capacity. And a homogeneous capacity means that you can run and you are able to run different functions in different points and substitute those functionality running on the same point, on the same physical element. So it's about something that is important. NFV is not. What is NFV is not is about bringing network functions to the cloud. To the current cloud. The cloud needs to evolve to achieve NFV, because the kind of loads and the kind of requirements of the data playing in networks are very different from the kind of requirements that current clouds can support, first. Second, is not running network functions on, how to say it without naming a company. Not to run this on general purpose, only general purpose computers that are the ones that are now part of the cloud infrastructures. It's an homogeneous infrastructure. It's an infrastructure that can be managed and used in an homogeneous way, but we are aware that, for example, you cannot simply run a mobile antenna on a server rack. You need specific equipment in some cases, but you need an homogeneous way of dealing with it. So let's say this. You separate the functionality can move over an homogeneous infrastructure that provides the capacity. Second, SDN. The idea is to decouple the basic functions of the network when it comes to forwarding and decouple it from what it comes from controlling in the wide sense. I remember very many discussions about whether we're talking about what's the difference between control and management. And at the end, the only difference is about the time on which the time you require for making the change in the infrastructure. Control and management are a continuum, and the idea is to gain programmability, and which is very important, and Sandra was mentioning this, is about abstracting the infrastructure, that you can see the whole the whole network infrastructure as an abstraction that you can manipulate with more or less sound mathematical models. The same way that currently is done, for example, if you think about with databases in which you are manipulating data records, disk records, memory positions that you are manipulating, assuming that you are manipulating these using an algebra. The idea at the end is achieving that goal. So they are deeply related. They have been historically separated because the networking community, the researchers started to talk about SDN before a few people got together in Paris by chance 4 years ago or so, and we coined the name NFV. And there has been this, some kind of struggle of the SDN community telling somehow that NFV was a particular application of SDN, of the NFV community telling that at the end SDN was only some aspects to support the NFV principles. But in fact, they are deeply connected, they are very much intertwined, and if you think about that, achieving NFV is possible, and the first experiments we made on NFV didn't use SDN at all. It's possible, but it's extremely difficult. And if you think about that, most of the use cases outside of the current data centers where SDN is more or less massively used are related precisely to some kind of virtualization of the network functions, because it's when it makes sense that you have a software-based infrastructure that you can move. Since you have something abstract, you can move programs around and you can do what are related to the goals of NFV. And this is something that is being recognized. There is some alignment. There's a strong alignment between the ETSI activities and the activities in the ONF. There have been documents we have been discussing and making, if not 100% compatible, look in the right direction. And internally we are trying to start talking not about SDN or NFV or SDN/NFV, and we have started to use the software networks in general. And this is a term that we are using currently in the 5G PPP, that for those of you not familiar with the European research jargon, is an initiative that is funded by the European Commission and the European industry precisely to advance in the achievement of a real 5G network, including not only the mobile and spectrum consideration, but including as well the aspects that deal with the new architecture supporting the environment in which 5G will happen. This comes from a document that precisely Marie-Paul has been leading the team doing this, which is precisely an analysis of how NFV and SDN were interconnected, and it's an analysis in which parts of the NFV architecture, that is the big diagram in black and white, you could have different elements related to SDN, where you can have SDN applications that can run for sure as part of how you manage the infrastructure, which is the first mention I made to SDN becoming the substrate supporting NFV. But you can have SDN applications as well as part of the OSS and as part of the evolution of the OSS, which is one of the main implications that SDN would bring, is precisely the fact that it should simplify or at least make us think in a different way of managing operations in the network. And you can have SDN elements in many parts, because it's not only that you have it in the infrastructure, you can think of a VNF, a virtualized network function, being controlled by an SDN controller that can be elsewhere as well. So what does this allow us? Well, is about applying software principles. This is a general architecture of a proposal we made some time ago on precisely an approach to network development based on platform and integrating the several layers of cloud, infrastructure as a service, platform as a service, software as a service, and mapping it to the concepts in an operating system. So the idea is that allows you to apply the IT and software engineering principles to the development, the planning, and the operation of networks. And that includes things like thinking in terms of the operating system structure, things about drivers, things about file system, think about processes, etc. Apply something that is very important, which is integrated development environments. We keep hearing about the problem of the time cycles for developing and operating and deploying network services being extremely long. One of the things we lack is tools, rather than the typical map of the network. It's tools that allows us to do things like debugging. We cannot debug a network right now. We are working on it. You can debug a network. Sandra was mentioning this morning the idea of the compilers and the PIF. And the idea is to have compilers, to have debuggers, and to have something that is very important, which is the possibility of integrating application and network development. The same. We are now in a project in which we are working with something that is a module that integrates with Eclipse. So the idea is that you will be writing the Java code of your application, and the Java or the Python or the whatever code of your network, dedicated, focused on being optimized for your application. Apply machine learning, why not? APIs, DevOps, or something similar. The possibility of making real tests of small slices of the network, making initial tests of how they behave with respect to certain users. And this is something, when it comes to the regulatory questions, is precisely this is the principle that I think we should apply here. We are moving software. We are moving operating systems. We are moving programming. And the regulatory principles that should be applied with software networks should be the same that could be applicable to, in general, any kind of software construct. And for this, I'm talking about how this will converge and how this will align with the interest of customers, and the interaction between different operators is about the idea of intent. Intent is something that has become it's a term that has become very popular among the software network practitioners, but essentially it's an upper layer of abstraction, simply that, if you think about this. But it's about concentrate on what you want and know how you do it, which is something that in networks is a real achievement. Think about that when you talk about whoever is a specialist in networks, you say, no, he's a specialist of software on radio networks. She's a specialist on fiber. It's about that you have the concept that the rest is about that you are a specialist on networks, the same way that you don't need a specialist on disk, which is the name, on these surfaces to run a database. You have very few of them that are taking care and exposing the appropriate interfaces and the appropriate abstractions. And that will support common interface for applications, and again, for vertical for applications and users, horizontal for collaboration among different operators. There are several ongoing activities in Etsy. We have plans, hopefully, to start thinking about how to map intent onto NFV, in ITF. Open Daylight is looking at this as an example of an open source project, the ONF, etc. And just for you to know, this what you have on the top left is precisely an example of this integrated Eclipse environment we are working in, just for you to give an idea of how it will end looking. So the idea is that think that we're moving from a world in which everything was discrete, clear, separate boundaries, separate interconnection points, if you like, to something that is a continuum. The same continuum that IT has been dealing with for quite a while. For quite a while, at least since I remember the good old days when I started working with this, in which if you were a financial application programmer, you were running COBOL. If you were scientific, you were doing Fortran. If you were tweaking with the internals, you were dealing with assembler. And that was all. You were scientific, you used Fortran. Right now, you know, it's a whole continuum when it comes in languages, solution, the different threats and different ways of dealing with the possibilities that you can have. And something very important, you always have a human in the loop. You have always somebody thinking of what to do and implementing workable thoughts, which a program is no more than that. And the important is that there will be no longer, during the lunch I was talking with Cara about this precisely, don't think that right now we are very used in the network space to have a fixed architecture. When I mean a fixed architecture, is not an architecture that is not mobile. Fixed in the terms that it has been fixed for quite a while. You have the aggregation stage, you have the gateway that is connecting you to the IP, you have, there is where you are allowed or you are supposed to be locating services, IP-based services like firewalls or load balancers, etc. This would not be necessarily the case any longer if we are talking software. The same way that you are not mandating how many processes you are using, for example, to manipulate a payroll database. And depending on the organization, depending on the tools that you have, depending on the history of the whole organization, you are running different modules, different processes, structured in different ways. That would be possible. And that would be possible almost dynamically, not as dynamically as it's supposed to be in the DevOps world, but at least you could choose one day to use one architecture and in 2 months' time to change the architecture. That implies that you have many additional degrees of freedom. It's not about that I will buy my broadband gateway from this vendor or those other vendors. It's whether I will have a broadband gateway, whether I will put my layer 2 to layer 3 boundary here very close to the user or there very far from the user. Because many reasons, efficiency, the kind of service, the kind of customers, whatever. This is something that is going to happen. Well, much smoother migration paths won't be that you have to make the changes all over your network and go much and take strong decisions and with much shorter time spans. And again, the basis for this will be precisely this additional layer of abstractions that is now called intent-based interfaces that will expand and blur the limits of the realms, but they are essentially very hard to regulate. How you regulate the concepts in a mind, because essentially is what we were talking about. So now coming to the particular questions, I have made I guess that you remember the long formulation because I have made a summary of them in the headings of the slides. When it comes to stronger control over incumbent networks, this is something that is technically possible and could be done. You can have a controller that is dealing with forwarding elements in SDN that are not in the same realm. That's theoretically possible. You can have functions that are located in the infrastructure of a third party. But so far, the practice so far is that we have addressed only vertical integration. By the way, the same that happens with cloud infrastructures. Don't tell me that from Azure you can use AWS at all. Even, I don't know if you realize that if you are using cloud services right now, you are completely vendor locked in, completely. Making a migration of what you have from a cloud provider, providing you, well, if it is infrastructure as a service, you are so-so, apart from the costs of moving a huge amount of data and programs. But if you are using platform as a service, you're using software as a service, you're completely locked in. And this is something that is normal, it's assumed, it's natural. You cannot, it's quite curious that we the operators are required to guarantee number migration, and no cloud provider is required to guarantee any migration at all. So it's a common practice, it's normal. It's normal, and we have followed the same path because it's the least resistant path for this, vertical integration. I will provide my own NFV, my own NFV infrastructure. I will provide my own forwarding elements. I will take control of my own controllers. So multi-tenancy is only considered right now, at most, at the intent layer, at the point in which I have several tenants that are requiring me different services, and I will provide them according to my internal, and which is something that if you look at the math specs are very much related to that. They are not exposing at all the infrastructure, but they are exposing a particular network model, that is this carrier Ethernet model, but doesn't care about how things happen inside. And well, trust and security models, if you allow me, and even being this being recorded, the current technology for trust and security models, when it comes to multi-tenancy or comes to multiple administrative domains, simply suck. I mean, they are very limited, extremely limited. They are very naive. They're assuming that everything happens inside the same domain, so you can rely precisely on the trust links that are established outside the technology. When it comes to horizontal integration, we are thinking about interconnection protocols. We're talking BGP. We are talking about extending a little bit BGP so you can give a hint about the topology you want, or you can give a hint of what you would like to see happening in the other controller. And but these are more than enough. That they have been there around for quite a while, and well, they are able to address the realistic scenarios that we are considering. Going further than that, extend it to a third-party control. Think about this as a third-party control. Think about that is a bank not having an interconnection of their compensation schemas with among accounts. It's opening up their database to another bank directly. So you can write on their database. This is something that is going very, very, very far. And this, frankly, is not happening in any other sector of IT applied to whatever other environment. In all those environments, the horizontal relationships at much are applied in terms of interconnection protocols. Technically feasible, yes. Well, technically thinkable, yes. Technically feasible, that depends very much on how you apply security and trust, and something that is extremely important is accounting. How you account if something nasty happens to the network, how you're able to prove that that nasty thing that happened was the fault of someone else, not yours, the infrastructure provider or the infrastructure user. And for detection, where do you point the fault? Second, network on demand and network function as a service, for sure. That's what was one of the original targets for software networks from the beginning, even inside the data centers in which SDN was initially deployed. One of the ideas was precisely to dynamically build this network as a service. And again, your friend here is intent, because you're not talking about the how, you're talking about the what. I want, as a service, I want X, Y, and Z. You will get X, Y, and Z, or X, Y, and Z divided by 2, because it's when I can deliver to you. We need still, there are some proposals, and I'm glad, for example, last week we were in a meeting trying to align the information models when it comes to NFV. I was glad to see that there are some initial movements precisely having a sound and common conceptual model about what a network is, what the connectivity abstraction you can apply, very similar to what we have with SQL in databases. You cannot care when you're dealing with a database, you don't care about how this is implemented, how it runs, whether there are one or several processes, or what they are doing with these drivers, but you work with the relations, tables, and the algebra around relations. It's about the same. It's about saying, well, I will represent the topology as a set of connected nodes and oriented graph and with these properties, etc., and I will work with my language on top of it. Again, even SQL being a very well-established concept, a well-established base for a theoretical base for reasoning about database, there is this doubt whether it's something that is subject to regulation. Can you regulate SQL? Can you regulate the SQL interfaces? This is something that is tricky as well. Well, when it comes to the network function as a service, or the virtual network function as a service, is one of the original cases in particular of ETSI. The ETSI NFV group started thinking about that, about how you could consume a network function that was provided by a third party. You can inject traffic and collect traffic. It has not been addressed in depth yet, because most of us are being focused on this vertical integration. There are some initial experiments. You can see here, if you are interested on this, there are a group in the ITF on the management on security services. There is and a couple of research projects. I'm sorry about the use of Sonata, Bill. That Sonata has nothing to do with MEF, and this is something that we have to sort out in a certain moment, which are precisely on how you orchestrate, and you can remotely manage certain services. If you're curious, I can provide you plenty of references about that. And for sure, this is suitable for generalization. And this is something that I foresee there will be a market for VNF as a service in the future. Though, again, we will have similar concerns when it comes with security models that can be applicable. How you measure the performance and the utilization of a network function. How you apply accounting and traceability so you can point the root of a certain fault, of a certain problem. Question 3, the impact on the value chain. Well, let me say, simply think on the impact of clouds in the IT value chain. Has been high, for sure. Will happen, and there will be. This is a diagram I used some time ago for illustrating how many different players could appear when you were addressing the idea precisely of virtualized network functions. You could talk about someone that is providing only the infrastructure. Even you can think about providers of independent parts of the infrastructure. You can think about people that are tenants of the VNF. They have the VNF ready, running on a certain infrastructure, waiting for traffic to come and to agreements to make. You can have different users having administrative control. Whether you are dealing with a single VNF, that would be the direct customers of the tenants. So I want to use a firewall as a service, and I contact a provider of a firewall as a service, and I inject traffic there. Or you can think of users of a platform as a service. It's not only think about someone that would be willing to use an IoT gateway as a service, and the IoT gateway includes several different functions that are pre-connected and aggregated by this broker of functions. You can think about, for sure, a network service provider that would be the role of the current packing all those services, all those platforms, and packing them into an integral way of providing service to the topmost, which is for sure our user, the one who pays the bills and pays our payrolls. This is something that is for sure will happen, but currently we are exploring we are taking the first steps there, and all the experiments I'm aware of, all the scenarios we are working on are dealing with this vertical integration, because for the current structure of operators is what makes more sense. The relation with OTT providers, that is question 4. Well, currently, the current architecture of the network and services draws a very clear line. What is an OTT? What is an NSP? Though this is something that even now is becoming to blur. More and more, the big OTTs, the Googles, the Facebooks, even the Netflixes are becoming more and more service providers, though they don't have customers, but they have peering agreements. Since for an operator to provide the best service to their customers, it's very interesting to have a peering agreement with certain of these providers. Then they are playing somehow to be, if not formally tier 1, because they are moving in a territory in which everything is much faster than in our territory. So since they are not obliged they are not obliged by certain regulations, they can precisely play a little bit like we are OTT, but they are not exactly OTT because they are taking advantage of direct routing, for example, in certain peering points, etc. But now what will happen is that if you have everything based on software and everything is based on and running on software networks, and taking into account that all OTTs in general are using precisely software networks as well, the borders will blur completely. You will be able as well to play the same game. Well, with you. Network service providers will be allowed to play the same game and to integrate much more with the OTTs. The other way around as well. I mean, OTTs could become more and more network service providers if they feel like. And here, when it comes into play, is network neutrality. We have to redefine then, if we have a world in which the clear distinction of the famous, it's quite curious because we keep talking about the 7 layers. I only saw 2 networks based on the 7 layers, and they went away before the 90s. But we keep talking about the 7 layers. When, for example, the ITF model has only 5. But we keep talking about the 7 layers because it's something that helps us thinking about the whole thing. Even those 5 layers that the ITF considers will blur again. And we blur much more if you think about what will come with things like IoT or whatever we call the industrial internet, the 5G to come, etc. That will mean that network neutrality that is based now on this principle is about all packets are created equal and things like that will change because packets won't be equal any longer. We are talking about doing genetic engineering with packets, and this is something very serious because you will not say all packets are equal because all packets won't have 2 legs and two arms, and they probably will have very, very different shapes. And we will have to rethink network neutrality in other terms. Apart that, we will have to consider, again, security, which is something that, well, I have been working, before I joined Telefonica, I spent around 20 years working on security and privacy, so I tend to be a little bit maybe obsessed about the ideas, because we're talking here about multi-contact security. Again, you cannot you won't be able to distinguish again between application and network security. You won't be able to rely everything. No, we have a VPN. It will be like an end-to-end connection. You won't know where you will go through if you're using a virtualized network, if you're using a software-enhanced network. You will have to address collaborative management one way or another, because you will be sharing. To some extent, you will be sharing infrastructure. And there are things happen, for example, there is an ETSI group that is called about MEC, which is mobile edge computing, which is the fog concept. It's a cloud that is much closer to the user. It's a cloud that is highly distributed and pervasive. Or, well, we are starting to talk about MAMI. MAMI is a project about measurements and making a middle box friendly protocol, so you can move the middle boxes to the place in which they make less harm and are less intrusive with user privacy. And just to finish, as a conclusion, well, that's the problem. We're not sure what the future is, but the future is coming. It's coming, it's here. It will be a long time till we realize everything I was mentioning before. The fog is not, well, you never know, because there are things, couple of weeks ago I was in a meeting in which somebody remembered, do you remember what happened in 2009? 2009, the iPhone was invented. I was sure that the iPhone was invented when I was 16 or something like that, because the feeling is that in 6 years, it has become so pervasive that for us has been around for our whole lives, at least for me. So this is a little bit like that. We won't notice. We are bringing a complete new paradigm. Things are changing and are changing very fast. Currently, still, we are in the initial stages, and currently it's an implementation choice, basically. So the concepts still apply and will apply for quite a while, because, as I said before, with the 7 layers, they will help us in reasoning. I'm making a mental idea of how networks are. And in that respect, my request to those of you working in regulation is that, please, till the technology is clear and we have a clear new model for thinking about networks, regulation, and when we're talking about regulation, we're talking about law, something that has to be enforced not by technology means, but by formal and legal means, something that should continue till we have a correct way to reason about it. When it comes to the real fully software-enabled networks, we were talking about something that we shall to address. We shall address in something that it would be the same of the IT continuum, and it will be at last, as for example, those of us working with in research projects with the European Commission, they were talking always about ICT, and we will be talking about real ICT continuum. That's all from my side. Thank you.
Thank you very much for the very interesting presentation. Is there any question to this presentation? Okay,
Question or strong reactions?
Yeah,
the idea was precisely...
That was, you have been provoking. Now, I am also provoked. Since everything is unclear so far, there is a continuum of possibilities, etc., and you are still focused on vertical integration, does this imply, and we still don't have the new model, so better keep the legal framework as it is and wait until you know? I just asked this question.
Precisely is not, I would ask precisely not to force things or choose right now a winner horse of in the technology. For example, something that came to my mind with discussing this with some colleagues is say, well, what is in the mind of berec? Are they thinking about mandating that we have an open flow interface to third parties? That's something that concerns us, frankly. Because right now we still don't know, and just as an example, open flow is too low level and should not be. Before we have, I would be in favor about thinking in the future about some kind of common intent interface mostly for customers, more than interoperators, and to mandate as a way of defending consumers who say, well, no, to defend the consumers you have to support this, or at least these functions. That could make sense to me. But now it's too early for that. That's my view.
I think here we could really continue, but we should probably reserve that for the panel discussion.
Thank you very much. Now the workshop moves on to the sections with presentations from vendors. There will be 3 presentations of vendors. The first vendor is Nokia, which recently took over Alcatel-Lucent. The title of the presentation is SDN, Network Virtualization and NFV in Broadband Networks. The presentation will be held by Florian Damas, Government Relations of Nokia.
So it's not,
He was responsible for the development of corporate positions on key regulatory issues for Alcatel-Lucent and advises national regulators, and has also been elected vice chair of the Digital Transformation Working Group in Digital Europe.
Hear me? Yeah. So before I start, these slides are actually based from research projects from Nokia Bell Labs. So it doesn't translate into products yet. So software-defined networking and network functional virtualization are generating significant interest in the telecommunications industry due to the promise of creating extremely flexible networks that can be adapted to the needs of the services being carried, as well as to the needs of the customers being served. However, the emphasis of SDN and NFV has been around application in the data center and wide area networks, with little consideration of applicability to access networks. However, the principles of NFV and SDN can be extended to access networks, making them more dynamic and responsive while providing operational benefits. So today we are able to have differentiated service over broadband access networks. We provide mostly triple play or quad play. And in the cloud era, new services facilitated by broadband access are placing greater demands on the supporting access network. Services are migrating from legacy triple play to full service access that covers residential, enterprises, and mobile backhaul services. These new services, combined with legacy services and architectures, place a large set of requirements on access networks elements, such as DSLAMs, MDUs, DPUs, optical network units and OLTs. In addition, requirements associated with these new features can require a long time to market and complex operations and maintenance. When we look at the limits of today of the networks, we have limited service configuration, meaning that we can do per user service provisioning. We can do global traffic capacity provisioning. We can fix mapping of services to resources. There's no differentiation over the top. And the network is open to wholesaling, but there's a single ownership and configuration. So we have statically defined services and semi-static provisioning. Now the idea of is to see how we can add programmability and control. So how do we leverage network programmability to reach service flexibility and agility, to roll out and upgrade services, and to dynamically allocate resources to demand and congestions? Today, most networks are configured statically and partly dynamic, but it's not fully dynamic. Now, the objective is to see also how we can dynamically convert service policy into hardware configuration and add end-to-end intelligence in the networks. How do we also use network resources efficiently from core network, backhaul, access, and within the premises, customer premises? So we have a few challenges actually to reach programmability. We have network operations segmented to teams and tools. We have limited support of standard open interfaces to control hardware. And there's a lack of flexibility to change and move network function. So we had a presentation this morning of ONF. So I was just going to say that the SDN paradigm stipulates the separation of control and data plane, as well as centralization of control functionality. This allows hardware and software to evolve independently of each other and decouple the innovation cycles. SDN has been gaining momentum as it allows network operators and customers to exercise more direct control over the path taken by the packets. This helps networks respond to changing demands more rapidly and better align with the needs of the applications running on top. The activity around SDN is complemented by Network Functions Virtualization. So every single network device has to perform at least 3 distinct activities. And the objective of SDN is to redefine the relationship between network devices and control software. So we have data plan to process the transit traffic. We have to figure out what's going on around it with the control plane protocols. And we network device interact with the network management system through the management plane. On top of that, we have an SDN controller, which is actually the core part of the network of intelligence to enable the control logic to be designed and operated on a global network view, to manage the network directly by configuring the packet handling mechanism. And also, the central point can represent network as logically separate slices. Today, at the core network and data centers, probably tomorrow in the access networks. So technology is evolving today in the access. We already have a standard, the first standard on TWDM-PON, meaning that we will be able soon to do wavelength unbundling on access networks over fiber at a speed of 10 gig symmetrical. So instead of doing traditional slicing with VLAN and the use of bitstream, we can think of SDN to actually manage this layer, having a network hypervisor that will split and control virtual networks. And each slice will be isolated from other slices, meaning that a slice will represent a pair of wavelength. And with the TWDM-PON standard, we could go actually up to 8 pairs of wavelength. So we have 2 applications as an example. The first one is open access. So multiple virtual network operators use shares of a common physical network. So we have a single fiber outside plant. SDN can realize open access through virtualization and slicing of network resources, wave-linked in that case. Traffic flows representing services between each provider and their end customers are defined in a central controller bound to specific policies, attached to resources, and measured at a service time. Slicing can be achieved by providing network abstractions presented to each operator as an SDN programmable infrastructure. Policy constraints will determine the level of control available to access seekers, enjoying physical unbundling, while ensuring logical separation of traffic and configuration between tenants. The second application is service partitioning. So independently manage slices of the network for different types of services, enterprise, residential, mobile backhaul, VPN, etc., with a greater granularity and dynamicity than engineered partitioning. One such network service requiring dynamic reconfigurations is the transport of next-generation 5G wireless. 5G is expected to reach much denser deployments of wireless access points and base stations, which brings opportunities in unifying the transport infrastructure of wireless and wireline access. However, the requirements for transporting 5G traffic dictate low latencies and high throughput. For wireless traffic to reliably share link capacity with residential network services, network element functions will need to be dynamically reconfigured in response to changing traffic patterns. Now you can see today that in the case of network unbundling with SDN, you can recognize the different interfaces mentioned this morning, northbound, southbound. We can have, with SDN, we can enable a level of control similar to physical unbundling. We can add flexibility of deployment similar to bitstream unbundling. That requires access network resource virtualization and separation, meaning a change in hardware and software practice, separate capacities in terms of memory, process, and firmware. That also requires new management paradigm and mechanism. So we also have network function virtualization, providing applications on the network. We had an overview also in the previous presentations. The promise of NFV is the separation of network functions from specialized hardware in order to enable mobility of network functions and to stimulate rapid deployment of new functions. NFV affords new IT-like agility to onboard, scale and shift resources to accommodate changes in network demands and requirements. This optimizes the use of network resources while significantly reducing the time it takes to introduce and ramp up new services. One example. One example is the virtual residential gateway. So we could have a combined SDN controller and a virtual residential gateway applications with element management system. So the SDN controller learns about network topology and capabilities from EMS. The control protocol is based on OpenFlow. We have multiple applications in virtual machines, NFV, and the features are not linked to hardware. So part of the residential gateway will be bridge on the customer premise, and we have an application on the network of the operator. That allows to have more rapid software and feature upgrades and add new function capabilities. So if I try to summarize SDN and NFV, so the accelerating pace of service innovation and the shift to cloud services increases the dynamicity of network traffic and increases the importance of having a responsive and adaptable underlying network. An access network without programmability afforded by SDN and flexibility of network functional virtualization will not be able to fully utilize network resources and will impede the introduction of new services, especially the dynamically changing cloud-based services. Now, what to virtualize on the access node? So first, the applications, including protection, mobility, network slicing, the management plane for the access node. We can also decouple from the hardware non-real-time control plane, so the SDN controller, the OpenFlow. But what will remain in specific hardware will be the real-time control plane, the data plane, and the forwarding plane. So if we go into details, how does we translate that? What will be a software-defined access node? First is the separation. Separation of control plane from forwarding plane. So decoupling, as I mentioned before, the hardware development cycle from software development cycle. Reducing the development and testing time. And the programmable forwarding behavior allows new services to be introduced without changing hardware. And then the second part is openness. Open configuration, management, and control. So using the Yang data modeling language to model the software-defined access node. Rely on the NetCoff protocol for configuration and notifications. Relying on OpenFlow for control of forwarding behavior. Enable also multi-vendor network management systems. And give operators end-to-end control. And the third point is the abstraction. How do we hide details of distributed access network, making it easier to manage and control? And also this network hypervisor that will allow slicing of the access network for different virtual network operators, or types of customers, or types of service. Now, we can already do that today without SDN and NFV by allocating specific wavelengths on the TWDM PON. But SDN and NFV will add a much more way of dynamically allocating resources than what we can do today in access networks. Access networks, backhaul networks, and core networks. Now, what is done today also with Broadband Forum? One thing we are looking at, with the access nodes, we are looking at what will be the requirements to support SDN in access nodes. So the OLTs, the DSLAMs. We're also looking at the Yang models for the access nodes. And we're looking particularly today at the fiber distribution point. And one technology is GDOS-fast. And the reason for that is that if operators deploy FTTDP, which actually is backhauled by point-to-point GPON, XGPON1 or NGPON2, so that means we have a FTTH backhaul equipment, and then we end up on copper or cable with G.fast. The issue we run into is the number of remote nodes that will actually increase significantly, increasing, by the way, the importance of efficient operations and maintenance. So that's one of the reasons why today there's a demand at the Broadband Forum to look after that. And to end my presentation. So today, so if we look at regulation, we see that the NFV and SDN transformation occurs at non-regulated network segments, so core and aggregation. NFV and SDN improve service quality, including what we could call specialized services on non-internet access service, which actually require bandwidth and latency. And the upcoming net neutrality guidelines that berec will publish soon should hamper the capacity of the industry to invest and innovate through virtualizations of networks. So SDN, as we saw, could be extended to the fixed access networks and provide a level of control similar to physical unbundling, combined with the flexibility similar to bitstream. Okay. And we also see that SDN and NFV, through virtualization of the home environment and the access network, could actually improve the cost structures and business models of wholesalers' networks. And at the same time, serve new customer segments, OTTs, new media, M2M, IoT, smart cities, and so on. That's the end of my presentation.
Thank you very much. Are there any questions?
Yeah, Florian, it's great that you are developing all of this, but we don't believe a single word into your conclusion. I would say the way you see virtualization as promoting competition, especially on the access network, and replacing and bundling, we don't believe at all in this.
I said service competition.
Well,
I emphasize on service competition.
If it's the service competition defined with a grammar defined by the infrastructure provider, it will not be real competition. No competition without access to the passive network. That you can build competition when you can define your services on the passive network.
Yeah. So if we look at what could be the new framework for telecommunications, and we see the development of access technologies, the final rung could actually be wavelength. So even if we have SDN and NFV in the future, the last rung will still be able to enable competition at the wavelength level. So that doesn't stop competition to go further at the deepest level in the network.
Well, what we shall see with wavelength is whether we'll reach with wavelengths something that fills, that demand cannot use. If it's not the case, if we still have constraints, we'll need dedicated fibers.
I mean, it's possible at the TWD endpoint to go up to 8 different, let's say, networks on a single fiber outside plant. So there are some reasons why you may want to duplicate, let's say, the fiber for businesses, for example, in terms of, because you have different SLAs. But the question is, why not, let's say, have an investment which maximize actually the number of networks you can actually deploy by providing a single fiber outside plant for most of the customers.
Well, any active service of today, even if it's seen as the equivalent of a passive service, will be, I would say, just 3 years from now, something that is constraining you. So it's not future-proof. It's all things for the next 3 years, and then you're dead.
Okay.
Here is, please, another question here.
Good afternoon. I'm from Portugal Telecom, and as probably almost anyone as telco around the room, I am a customer of Nokia, and I would like to make a question about your last statement. When you say that the implementation of SDN and NFV could improve the cost structure of business models of wholesalers, and I would expect also as retailers. What can we expect from the industry in terms of reduction of the cost of implementation of services, based on the fact that, especially on the home environment, of course, that we are virtualizing a set of functions that are on the home gateways, probably on the set-top boxes for TV, probably no more than that. But we have to take into account the cost of implementation of those functions on the cloud or on the data center, plus the licensing model that you are going to put on top of it. So what can we expect in terms of cost reduction?
So I say it could improve, but I will not give any details.
Here's a further question, please.
Thank you. My name is Klaus Martini from Deutsche Telekom. I have a question about, you mentioned Young and NetConf and BBF and a couple of times the open source community. How do you see as a classical SDO should be involved in the deployment of SDN and NFV?
Who should be involved?
The classical SDOs like SDN, NFV, CUP, BBF, or all this other stuff which are they care about NFV, because there nothing. I saw a couple of times open source. Of course, there should be involved and there will be involved, but what about the classical SDOs?
Yeah, it's not clear today how we can rely on IPRs and open source interfaces. This is an ongoing discussion at the moment between the players.
But that is one of the key questions that should be solved before we are talking about deployment, this kind of stuff.
I'm just not the right person to respond to that, because I
work
for government.
Mentioned on your slides, nothing else.
Yeah, but I work for government relations, so I'm not a technical person working on standards.
Then I have a second question. Also, you mentioned, which is good, the network management stuff, the OSS, for example. How do you see that? That should be solved in the future as well, because for the time being, we have a classical OSS behavior, means a lot of things are static, but we have now in a flexible SDN and NFV deployment or network. How will be impacted OSS?
So I have little information on that. I know that we're working on making an OSS open to different SDN and NFV platforms, but that's all I can say.
Okay, thank you.
Okay. One last question here over there, please.
Thank you very much. Ines Velasco from ECTA, representing the competitors. I was very interested on your point on TWDM and how this is readily standardized to be implemented. So for the time being, the best for an alternative operator when having access to a fiber network is to have a point-to-point fiber where you can just do a proper unbundling. If you have a PON network, for the time being, you would have a VULA product, let's say, over it, until you could have this WDM implemented. This has been what we have seen, you know, in the regulatory discussions. So now it seems that we have this WDM product ready, which would allow you to unbundle through the wavelengths point-to-multipoint fiber. Just to confirm that this is what I understood, why this hasn't been implemented, and what you would see as the key differences between a VULA product over a point-to-multipoint network and this WDM unbundling.
Okay, so I'm not going to agree with your statement on fiber unbundling. We can also unbundle PON networks, and it's done today in France. Second case, for TWDM PON, now it's a question of cost. How much actually, what are the costs of optics? And that's probably tells us why today it's not deployed. And it's only technology which is on a trial within different operators' networks. Now, comparing bitstream to TWDM PON, I think if we try to position this on the ladder of investment, I think they're very different. With TWDM PON, you can expect that the point of interconnection will be at the central office, whereas we've seen in a previous presentation on QSC that you can have a point of interconnection with bitstream at a higher level in the network. After that, on one hand, you have if you rely on TWDM PON as an operator, you have full control over the network elements that you deploy. You can decide which firmware to roll out, depending on your own requirements. Whereas for bitstream, you have to rely on a wholesale product, and that's so you have to be clear on the interface you wish to have with the access provider, and also the kinds of, let's say, features on this wholesale product you would want to use.
Okay, thank you. Just a short question from my side. You have mentioned that all the information of the presentation are based on activities of the labs, but not information on concrete products. Will Nokia actually develop products and solutions which will enable fixed network access, which provides more control over the network of the incumbent?
I'm sorry, but I cannot answer that question for now.
Okay, thank you. Okay, we move on to the next presentation. The next vendor is Fujitsu, and the presentation will be held from Chris Gellan, Head of Innovation Network Telecoms of Fujitsu UK and Ireland. Chris, he is actively involved in the implementation of SDN and NFV solutions, was chair of the UK NICC working group, on the board of the Multi-Service Forum, and is co-author of the book Converged Multimedia Networks. Please, Chris.
Right. It's probably worth clarifying that I'm a vendor. I'm kind of a systems integrator, kind of an operator. We have our own high bandwidth fiber network in some territories. We don't compete with other operators, so it's not quite as simple as saying I'm just a vendor. And I'm trying to give a view here that kind of steps across the piece rather than just from a perspective of a vendor. So we'll see if I succeed. So the first thing I was going to talk about is unbundled architectures in the UK, specifically for next generation access, which is our fibre broadband product. I wasn't really expecting there'd be any other mention of access or broadband or bitstream, so it shows how much I know. But really what happens in the UK, and you can see the architecture, is there's a set of standards written by NIC, which is the Network Interconnect Consultative Committee. They were asked to do that by Ofcom to support their VULA unbundling solution. And what this is fundamentally a bitstream product with the architecture, if I have one of these, with the architecture there and there. So what happens in the UK is you have an ALA provider who we know and love as BT Openreach, because they are fundamentally the only provider of ALA services at any volume as far as the access network goes. And that's VDSL based from the cabinet, and they feed that back in through their network to a set of handover points, which are quite a large number of those, but not every local exchange. And at this point, we have an ALA NNI, and they hand it over either to the service provider, and if you're a particular service provider, you've got a very large unbundled footprint, or they hand it over to a backhaul provider. And interestingly, this will then transport it to the ALA user, who you could also call a service provider. ALA stands for Active Line Access, and it looks a lot like an MEFE line service. So bad news, it really is all about broadband access, Bob. And we have defined all of these interfaces, and we've contributed back into the broadband forum, and you'll find it's probably made its way into their next generation standards, or at least they're compatible with it. Interestingly, this bitstream service, we have a bottleneck here, because once you get out of the regulated world of Openreach, you have then the problem for some providers of backhauling this bitstream service to a more central location. Well, the problem with that is there's no regulation there, and you find they charge you a premium for a layer 2 service, even though to do a layer 3 service they have to add a router that you don't want and adds no value. So it's interesting, and the reason that I mention this is just because when we consider what SDN and NFV is actually going to do, we've got to consider this kind of unbundled architecture where those exchanges that the ALA provider has may actually be subject to local loop unbundling, may be subject to hostels where people can put their equipment, and this has some implications for how you actually, some of the scenarios when you come to looking at NFV and how that gets distributed. Okay, so if I now look at the broader SDN and NFV landscape, so the first thing to say is there is a plethora of solutions and options, and plethora is a deliberately chosen word. It means a very large amount of something, especially a larger amount than you need, want, or can deal with. And I think that's probably true here. But each of them have their place. So in the access network, we don't tend to see so much of SDN at the moment, but OpenFlow would possibly be an interesting protocol there. In the core networks, you have some interesting technologies. You've got PSEP, Juniper North Star controller uses that one. You've got an interesting innovation from Cisco, segment routing, which is IETF Spring. You might use that if you want to control and steer flows to particular data centers. Sitting above all of that, you have your SDN controller. And again, we don't see so much of it in the WAN at the moment, but it's probably coming. And I think there's a general consensus that you've heard today that the original vision that OpenFlow would allow network slicing at the bottom layer doesn't really apply. And if OpenFlow is used at all, it will be internal to the network, to the carrier. And you've effectively got an intent-based interface to allow you to instantiate services over it. That looks a lot like today's today's BSS interface. So if I look at the BT network, there's a very rich BSS which can do pretty much everything and anything an intent-based interface can. Probably much more slowly, and possibly not in quite the way you want it, but you can kind of see where this is going. And you see innovation that isn't SDN related, but it allows you to expose a virtual routing function in IP, MPLS, BGP, VPN. So when you move into the data center, you move into a much more rich environment of SDN and beginnings of NFV. And of course, most of the SDN in the data center today is done by VMware NSX or Cisco ACI. You can now have a big battle over which one fits your particular solution, but that's kind of where it is at the moment. They're not really open, but they are SDN. They're cloud, what I would call cloud networking solutions, so you can't really deploy NFV on them. But they are an example of where SDN has kind of found a niche today. So a lot of the discussion today is how's that going to roll out into the wider network, and how's NFV going to fit with it. So if we then just look at some of the use cases around another interesting little piece, optical and SDN, which we haven't really talked about. One of the things that's happened in optical networks is that OTN has appeared. Now OTN is an interesting technology because we can now shift and switch 10 gig payloads at the optical layer. What that means is as bandwidth goes edge to edge towards 10 gigs, I don't need to go to the routing layer to get it through my network. Saves a lot of bandwidth, it saves a lot of interfaces at the edge of the network. So in the old world, up here, if you wanted to send it to 3 different destinations, you needed 3 sets of optics. In the new world, I need 1 set of optics, and because we've invented switching, what a great invention that is, we can now switch it in the network. What you tend to find now is you've got an SDN controller doing that, which could either be driven by an orchestrator. So if you're a media company, you want long duration flows, you schedule them and you orchestrate them, and you connect them using these things. However, you could also integrate it with a packet network. So conceivably, this is an example both of a new kind of access that SDN enables, edge-to-edge 10 gigs. And interestingly, it may be the beginnings of the breaking of the consensus that has sat in networks for so long that you have an access network, you have an MPLS network, and that's kind of job done. You may find, and I'm not saying you will, but you may find the MPLS segment shrinks as your end-to-end bandwidths climb up towards 10 gig. If your edge-to-edge is less than 10 gig, you're definitely still in an MPLS world because you've got to be able to switch the microflows. Okay, so to another question that was asked about carriers offering NFV as a service, and this is really why I was talking about our unbundled architecture earlier. We see quite a lot of things happening here. So some carriers, I won't name them, are looking to move what they call the service provider cloud, which is effectively the data center, towards the edge. So where today you have a service edge router, is a local exchange, you can effectively deploy Xeon servers or anything else in there. If your exchange can take servers, most of these exchanges can't, and there's quite an expensive engineering program to make a telecoms exchange suitable for deploying general purpose compute. Air conditioning, not so much. So that means there's a significant amount of investment. So when we talk about what services could be supported, the carrier themselves can, once they've deployed that infrastructure, can take advantage of all the benefits of NFV that we've talked about. So the ability to deploy, I don't know, a DNS server to where you want it, the ability to do service chaining and all that good stuff. They can also resell that to other people. so they can offer these services. So they can, in an ideal world, they'd offer virtual network function NFV infrastructure as a service, by which I mean it's an infrastructure as a service, the ability to order compute, storage, network and orchestrate it, but in a way that's compatible with NFV. So as Diego pointed out, you actually need, in that environment, to be able to do certain things you don't do in cloud. You've got to pin your network functions to processors. You've got to avoid crossing the NUMA boundaries when you're doing memory lookups. You might want to use SRIOV. It's a completely different dimensioning solution. But that would be the ideal solution. And then there are variants around it, like so just being able to deploy your own VNF or choose from a menu of virtual network functions. You also see variations of that. You can get now OTT providers doing NFV, doing virtual CPE in the data center. So they take a bitstream service if they can get it, and they terminate that in the data center, and then they run their own CPE there. The problem with that is that's a great operational saving. It's a fabulous business model. You consume all of your savings because somebody's charged you a premium for a layer 2 transport service. But hey, you know, that's life. And then there's another variant of that where you actually deploy virtual CPE in the customer premises. So a CPE, but it's virtual and it's in the customer premises. And again, you can orchestrate that as before. And then there's a variation of that again where the carrier can offer a NID, network demarc device, which is just effectively the boundary between their network and the customer premises. But if they've got the ability to run x86 on it, you can deploy your virtual network functions on that NID. And I've certainly seen that done, or being done and being talked about. So there's a wide range of options here. But one of the key things is there is continuing battle, as we know, between the OTT providers, the alternative carriers, and the carriers who've actually had to pay for the infrastructure and run the infrastructure. So depending where you are, this either makes perfect sense as a carrier because you can control what goes in the exchange and how you use it, and only you can use it. Or if you worry about spending all that money on the Xeons and then having someone turn up, just put everything in your data center or in your exchange, remove all your value and turn you into a bit pipe carrier, that's a tough sell to the shareholders, I think. So I think you will see unbundling's been great for competition in lots of ways, but it might be a blocker to some of this innovation. I'm not going to blame carriers or OTT providers for that. That's just the way the world works. Another thing that we've talked about is, well, can we use SDN and NFV to enable more control over networks? And that's interesting because that's just disappeared. Oh, great. Oh, well, there you go. I have a missing diagram on that slide. And if I could remember what it said, it'd be great. Okay, it's just another use case for the problem. And unfortunately, it's the interesting use case. So the scenario here is we've all talked about the northbound interface, and really this is absolutely critical. So if you want to enable greater control, you've got to have a northbound interface. And again, the same issues apply with what you can do and whether it's in the interest of the carriers to let you do it. And you can see some of the work has moved from trying to force open flow in to move to intent and Boulder and Aspen, all that good stuff. And one of the things is it could allow the OTT providers to exploit network capabilities, and it could allow the service providers to open information about their network to the providers. And you will actually do this where it makes sense for both people, I think. So there were a couple of scenarios. The most interesting one isn't up there, but I'll describe it. It postulates the theory that you can take a stadium, a sports stadium, and let's say somebody on a mobile network is busy watching a whole load of the highlights of other games at half-time. They're on the BBC or whatever your broadcaster feed is, looking at the highlights. If their application can somehow signal, or if their network provider can detect that all of these video streams, unicast video streams, are being used, it can request via the EPC a multicast service which can get provisioned, and then the application can go tell everybody's mobile to go pick up that multicast service and stop spamming the network with a load of unicast streams. And that's an example of a service that would be enabled by this, which would be beneficial both to the OTT provider and to the carrier. And the other scenario is an example of a customer wanting to insert content filtering into their service chain. So again, if they've got an application portal, They can request the service can get orchestrated and it can get deployed, and if the carrier's got the northbound interface, it can get deployed into their service chain. Whether that gets deployed in the data center, in the service provider cloud, that's really down to the architecture in the carrier network. So, if we just now step back and say, what can we conclude from the technologies as we see them? I think everyone here would agree that SDN and NFV are important technologies. I think carriers would adopt them based on business need, and one of the issues here is the carriers really decide what gets adopted. Vendors can come up with great ideas, but if they don't make sense to the carrier, they just remain impressive slideware or an expensive write-off. I think in some parts of the network we see SDN already embedded to support cloud networking and virtualization. We're not really necessarily seeing wholesale NFV quality deployments of this, but they're kind of there. The stuff that has happened is typically constrained, single operator and single domain. So the simplest use cases get defined first, which isn't really a surprise. Another issue is when you deploy SDN and NFV, your OSS and your BSS don't go away. They're still there. You've still got to bill for things. You've still got to work out how to integrate them. There's quite a large integration cost. And there is a key challenge around all of this, trying to make these things easy to deploy and operate. Classic example of this is some of the NFV deployments, even relatively simple scenarios like virtual CPE. When it breaks, it's not obvious what's broken. You know, is the problem that my virtual network function is broken? Is the problem that my infrastructure switch, whatever that is broken? Is the service chain properly built? Have I overloaded the hypervisors? How do I know what's going on? And also, in some of the scenarios, you see confusion between the layers. So people start implementing controls in the actual infrastructure layer, which is, they've done that because that's how you used to protect switches. But of course, if you put anything in the infrastructure layer like that, you hide it from the operator. So it's all got to be done up in the VNF. So it's going to be a challenge for this to work, but it is going to work, and solutions are coming. And definitely, things will progress from the relatively easy, low-hanging fruit that make most sense to carriers, OTT providers, depending on who's deploying it, and I guess eventually even the more complicated, multi-domain, right across the piece solutions will happen, again, where everybody wins. I think anyone in this chain, from the OTT providers to the carriers, can potentially block anything, and the vendors if they don't build it. So you're really looking at things where everybody wins as perhaps the earliest possible deployments. One of the things about all this is if you're a regulator and you're looking at it, the fundamental networking requirements remain. So SDN and NFV don't really change anything in that respect. What do we need? We need low-cost, ubiquitous connectivity for business and residential services. We need regulation only really when it's necessary to achieve that aim. And you can see where, I wouldn't say regulations failed, but you can see where deployment scenarios limit things. So for 4G, the Korean markets roll out cloud centralized RAN. Centralized RAN requires point-to-point fiber to your LTE radio heads, and then around 20-30 kilometers you put your hostel in and you deploy your base station, and it works brilliantly because it takes 120 base stations and it smooths out the edges, because the fundamental limitation in an LTE network is that edge. If you've got everyone sitting in the middle of the cell not moving, you've got a fabulous amount of bandwidth, but the spectrum is shared, not the bandwidth. So if they're all running around at the edge of the cells where you've not got the high quality radio, you've got low bandwidth per customer, you've got very small amounts of bandwidth. By smoothing out the edge, you can get an uplift for free of about 60% for the same spectrum. So that's a huge saving. Who wouldn't want 60% of their spectrum for free? And the answer is quite a lot of people where they can't get cheap fibre, because deploying fibre is expensive. So, and there are technology solutions looking at fixing this, and can we get it over copper, which is a barking thing to do, but that is the reality of network deployments today. So there are limitations. Regulation may help When you look at service innovation in this space, Ethernet bitstream services are fantastic if you can get them, because now I've got my, as Stephen was saying, I've got my layer 2 connection, I can put my NFV on it. It doesn't matter if I put it in the next to the customer, in the middle of the network, right at my edge of my data center, that's my call. But if I can't get that low-cost layer 2 connection, then I'm stuck. Can't do anything about it, can't innovate. So, one of the things that drives me personally nuts is when I see a premium being charged for something where I know the original service was layer 2, which is what's happening in the UK around NGA. It's nobody's fault, it's just the way the market is. Okay, so because I'm kind of between you and coffee break, we'll wind this up. So, as we've said, SDN and NFV offer significant benefits. Service innovation with fail-fast methodologies and increased automation. I love fail-fast as a concept. I could fail fast, it's brilliant. But what they actually mean by that, to be fair, is in the old world in telecoms deployments, you agonized over how big your deployment was going to be, whether you needed the big box or the little box. And if you got it wrong, you spent a ton of cash and you had to write it off. Or if you got it wrong the other way, you spent a ton of cash on a small box and hoped you could somehow make it work, and then you needed the big box, and then you had to wait 6 months and your service stopped working and everyone left because you got a terrible reputation for quality. In the new world, you come up with an idea, you deploy it on a Xeon server, you see who turns up. If loads of people turn up, you know what, you get some more servers, or you scale out the service. And you can do that very quickly. And if nobody turns up, you can turn the service off and you can still use those Xeon servers for something else. So, that's what all this is about, and that was the original ETSI vision that Don Clark and all the other authors of that original paper at NFV wrote. So, you will see, of course, application awareness in the network and network awareness in the application, where everyone wins. You'll see service chaining and portals, and yes, that will mean greater control for other operators and for customers of their services. You're not going to see the sort of segmentation that OpenFlow envisaged around being able to partition the network the way they do in academic networks. You just can't do that. The nature of modern merchant silicon means you couldn't predict, if you built the service, what resource constraints you'd hit in the switch. You are going to see that the northbound interface is going to be absolutely critical in all this, and it has been very, very slow. Maybe now in the ONF and some of the open source projects there is some traction, but it is still a challenge. So from a regulation perspective of these risks, what might you need to think about? As I said before, standard network regulation applies, nothing's changed. Net neutrality, which I don't have a view on, but if you do have one, this might complicate auditing it, because if eventually I can just drop things in and out of a service chain, then I can do naughty things to someone's service and quietly get rid of it, and hard to audit that. There is the problem that the carrier controls what aspects of SDN and NFV are exposed to the OTT providers and where that capability exists. And if you are going to unbundle, then you need to make sure you do it properly. So if you are going to mandate in-house carrier services, you are going to do this, in that regulation, you need to make sure that they don't cheat and they use the same capabilities and the management of those capabilities that they expose to the third-party providers. I'm not sure if any of that's really going to need to be regulated, to be fair, but if you are, you have to do it properly, in my view. It may be necessary, though, and I was interested to hear Diego say it, although he may deny it if you ask him again, that it may be necessary to regulate some network APIs across that northbound interface if it develops, if it becomes a bottleneck. Hey, I'm not saying you should do it now. I'm looking when we have a mature ecosystem. It may not be necessary because this may just happen naturally, and there's always that hope. And the other area is a huge concern, which is security of SDN and NFV solutions. So at the moment, we have a framework for security in networks. You have to meet the requirements to connect to a network. In the UK, we have all sorts of stunningly complex security requirements, and the price goes northwards as you go up and up the security levels. They're called impact levels, or at least they were for a reason. At impact level 2, it's kind of the PSTN. Impact level 3 is kind of government departments that matter. When you go up beyond that, you stop being able to do work, because in order to do work, you can't connect to people because that would breach security. And then you end up with things in locked rooms that only certain people have access to right at the top end. So from an NFV and SDN perspective, the worry is that people put in a solution that's easy to expose, easy to crack, and there's a significant loss of either a denial of service attack, or the whole network just collapses, or there's a massive loss of data. But again, common sense applies. If you're using an SDN and NFV service, if you're worried about your data, encrypt it. Don't rely on someone else to provide your security, because they may well get it wrong. And although you'll get sued when you get it wrong, at least you're not getting sued because somebody else did. So it's kind of really all I had to say, and I hope it's been of some interest. Okay.
Thank you very much for the interesting presentation. Any question? Please. I would give you my mind.
More than a question, it's to you. It's a question to, I would say, all the speakers. This issue about the security of SDN and NFV, well, triggers for me the following remark. It's, I would say, can we implement NFV and SDN without any proper role-based access control? Or if I take a metaphor regarding, taken from data protection, you may have access to some data, but for a given purpose, yes, and not for another one.
Yes.
For example, if you can see the network, you can use that for, I would say, to establish a connection, but you cannot use it for marketing purposes. A lot of this will be based on, you can have access to this, but only for this purpose. This is an alternative to having signaling to establish the call or the connection. You have access to a central database, but don't copy the central database for your marketing campaign.
Yeah, I mean, I think the fundamentals apply, that you've got to have access control, you've got to respect rules on data protection. But I guess just the risk with SDN and NFV is it's more complex, and it's virtual, and it's harder to audit. And that's kind of, and it's young technology. So if you look at OpenStack, for example, securing that is a challenge. Great idea, great product, fantastic project, but it is a challenge to secure it. You can do it, but the regulation is probably going to be about making sure the right people have done the right things.
Okay. Okay, please.
Well, what we are not used to do in telecoms, but which is done in other domains, is to log everything, and especially on the administrator side. If you're a pilot, you have the flight data recorder. Yeah. If you are an accountant, any entry cannot be erased in the books of the company. So I would say we do it for users, we don't do it for administrators. The network elements we have are very primitive in terms of the security capability that is requested to have this auditing capability.
Definitely, yes. I tend to agree with the principle. This Diego here. But the problem is that, for example, the example of a plane, what you're not allowing is when two planes crosses, one from Iberia and the other one from Lufthansa, is that the pilot in Lufthansa taking control of the Iberia flight. In spite of whatever, you log everything. And take into account that the proper log of what the Lufthansa pilot is doing, you have to be sure, not only because of the Iberia flight, but because of Lufthansa as well. So, I mean, it's the principles, I fully agree, but as Chris was saying, the problem is about the technology that helps you in implementing that. We are in the early stages. And personally, I tend to be rather optimistic when it comes to technology. We will arrive there, but it will take a little bit of time.
Okay, good, excellent.
taking the opportunity of having a vendor and an operator
Yeah, I'm very
at the
confused.
podium, do you think that it could be advisable that the BEREC launches an idea for having an economic study of SDN and NFV implementations, and taking the opportunity of your complaint about the bitstream offers? I would assume that it's not only in England, in the UK. Aren't they regulated or let's say based on costing?
Well, the stuff that is regulated based on costing, but not everything in the network is necessarily regulated, I think is the thing. But yes, I think on the whole, you do need to pay attention to that sort of thing. And especially with bitstream, I think it would be a significant value to look at that. But I think the issue about bitstream services and layer 2 versus layer 3 is not really related specifically to SDN and NFV. It's just a wider piece. And we've had some interesting discussions around the German network that I know nothing about, which suggests that you're right, it's not just a UK thing. But yeah, I think so. But I don't think it's an SDN NFV piece.
Okay, I leave the idea to BEREC to launch a study on the economics of implementation of NFV and SDN.
Isn't that too early?
The industry should say. The industry should say.
Wow.
They say that we don't. They say that we as telcos, we just don't buy because there is not a business case. They have to prove that there is a business case.
But from what I heard now, there is this plethora of possibilities. Shall we evaluate the plethora of possibilities?
Well,
I think that, to me,
There's
it
too many of
sounds
them,
as
so you
if that
can't.
was too early. I mean, my impression from today.
Yeah, I think so.
And I would like to add, it seems also that different providers or stakeholders may have a different view on how a network should look like based on SDN and NFV. So what would be the basic scenario? There is not really an agreement. You make a study for a basic scenario for 2, and the others say, oh no, that's not in the scenario I have mentioned. I have another.
Yeah. Yeah.
Yes, the European Commission is working on this topic and also has some studies on SDN and NFV.
We're expecting, I think, results in the middle of this year. So at least that's what I've heard.
Interesting.
Okay. Then I think we can move on to the coffee break. And we will continue with the next presentation at 15:45. As originally planned, at 15:45, please. Half an hour for the coffee break.